Assalamu alaikum students. Today we start exercise 1.4, continuous and discontinuous function. One-sided limit. In defining limit x tends to a f of x, we restricted x to an open interval containing c. Study the behavior of f on both sides of c. Both sides of c means if we have a c is equal to 2, we check the limit at 1.9 and 2.01, less than and greater than. However, in some cases it is necessary to investigate one side limit, the left hand limit and the right hand limit. Left hand limit means the value is less than c. If c is equal to 3, then the value is in left hand limit 2.999, close to 3, is read as the limit f of x is equal to L approaches c from the left. For all x sufficiently close to c but less than c, the value of f of x can be made as close as we please to L. The right hand limit means if x tends to c and c is equal to 3, then right hand limit means 3.01 greater than 3 and is read as the limit f of x is equal to m as x approaches c from the right for all sufficient close to c but greater than c. The value of f of x can be made as close as we please to m. The rules for calculating the left hand limit and the right hand limit are the same as we studied to calculate the limit in preceding section. Criteria for existence of a limit of a function. Limit x tends to a, f of x is equal to L if and only if left hand limit and right hand limit are equal to L. Now there is a piecewise function. We check its limit at x tends to 2 and x tends to 4. For x tends to 2, we have in limit side we see the two functions 2x plus 1 and 7 minus x. Now first we put x tends to 2 in 2x plus 1 and then x tends to 2 in 7 minus x. Here we have a sign minus and plus. X tends to 2 and above sign minus means the value is less than 2, but we put exactly 2 but consider it is a less than 2, and then 2 with a power sign plus, it is 5. Now both are equal values, therefore the function is continuous at x equal to 2. Now for 4, here from the limit, for 4 we have 7 minus x and x. 7 minus x as a left hand limit because here we have x is less than equal to 4, and for x is greater than equal to 4 right hand limit. We check when we put 4 in 7 minus x it gives 3, and then 4 put in x it gives 4, not equal, therefore it is not continuous. Therefore the function is continuous at x equal to 2 and discontinuous at x equal to 4. Continuity of a function at a number. A function f is said to be continuous at a number c if and only if the following three conditions are satisfied. First is f of c is defined. F of c is defined means the resulting value is not undefined and limit extends to C exist means left hand limit and right hand limit are equal, and at the end first and second part are equal, therefore the function is continuous. Discontinuous function, if one or more of these three conditions fail to hold at x at C, the function is said to be discontinuous. Now we have a function f of x is equal to x square minus 1 and x minus 1. F of 1 is not defined. F of x is discontinuous at x is equal to 1. If we directly put 1 in the function, it gives 0 over 0 undefined form, but when we simplify it gives 2. Therefore f of x is continuous at any other number except x is equal to 1. F of x is equal to 3x square minus 5x plus 4 at x equal to 1. We put 1 in the function, it gives 2. Therefore function is continuous. Now we discuss continuity of a function. We have two values for the function x square minus 9 over x minus 3. When x is not equal to 3 and x equal to 3, it gives 6. It means at x equal to 3 the function gives 6, and for any other values of 3 we put these values in the above function. Now given f of 3 is equal to 6, the function is defined at x equal to 3. Next is left hand limit. We for not equal we consider it left and right both function. We simplify the function, put the value, so it also gives 6. Therefore the function is continuous and its graph is this, because it is a linear function. When we simplify it, it is linear, therefore its graph is straight line. Now in B part we have only the function x square minus 9 over x minus 3 if x not equal to 3. Therefore g of x is not defined x equal to 3, because we directly put 3 in the function, it gives 0 over 0 form, and when we simplify it gives 6. Therefore the function is discontinuous at x equal to 3. The difference between two questions: in this first part it gives x equal to 3, the value is 6, but in this we have no values for x equal to 3. Therefore the B part is discontinuous. Its graph is like this. At 3 we draw open circle in the straight line, because the function have no value for x equal to 3. To break in the function, it means it is discontinuous. Discuss continuity of f at 3. We have a piecewise function x minus 1 and 2x plus 1. The limit where we check is x equal to 3. Now the graph, we draw its graph like we draw in the first exercise. F of 3, when put x equal to 3, in which function we put x is equal to 3. Here we see in first x is less than 3, and in second x is greater than and equal to 3. Where we have equal sign, in this function we put 3. So second function contains equal sign, so we put 3 in this function, it gives 7. And for left hand limit, we have a function x minus 1, and for right hand limit we have a function 2x plus 1. But both the answer are not equal, therefore the function is discontinuous. From also diagram, we have two different lines break in the function, therefore it is discontinuous. Okay student, this is the exercise. Now we start exercise 1.4. Now in first question, we have a function f of x to x square plus x minus 5. We apply left hand limit. It gives answer 2, and then right hand limit. The above sign plus shows right hand limit. Add 1, and then f of c. All the values are same, therefore the function is continuous. Now again in this question, we put x tends to minus 3. For left hand limit it gives 0, and for right hand limit it gives also 0, and for f of c it gives also 0, therefore the function is continuous. Now in third part, we have a magnitude sign at x equal to 5. For left hand limit x tends to 5 minus. We also discuss about minus sign above in the value 5. It shows the value less than 5. If we put value less than 5, it gives negative sign. We remove magnitude and mention minus, but at the end it gives 0. For x tends to 5 with plus sign, it means the greater value than 5, but it also gives 0, and f of c it is also 0, therefore the function is continuous as x equal to 5. Now in this question we have two functions, 2x plus 5 and 4x plus 1. For x less than equal to 2, it means we put left hand limit in the first function and also f of c in the first function, and x greater than 2 for 4x plus 1. For right hand limit we use 4x plus 1. Now left hand limit, we use the first function, it gives 9. For right hand limit we use second function, and f of c equal sign in the first function, therefore we use first function. Therefore three values are equal, the function is continuous. Now we have three values, x less than 1, 3x minus 1 for left hand, x is equal to 1 for f of c, and x greater than 1 for right hand function. So first we find left hand limit, x tends to 1, 3x minus 1 it gives 2, right hand limit 2x it gives 2, and f of c it gives 4. But the three values are not equal, first two are equal but the last is 4, therefore the function is discontinuous. Now we have three functions also and two values for -2 and 2. Now we check the limit for -2 and +2. If we see at the limit for -2, above two function for -2 and second two functions are for +2. Now for -2, the left hand function is 3x, and for right hand we have the second function, because here we have x greater than -2, it is the right hand function. And for f of c, for -2, equal sign in the first function. Now all three values are not equal, therefore at -2 it is discontinuous. Now for true, we have second function for x less than 2 in the second function and x greater than equal to 2 in the third function, it is 3. Now we find left hand function, and right hand function it is only 3, and f of c it is also 3, therefore the three values are same, therefore the function is continuous at x equal to 2. Now we have a function, limit is -1. For less than equal to -1 we have a value x plus 2, and for x is greater than -1 we have a value c plus 2. For left hand limit, above value x plus 2, its answer is 1. For right hand limit, we have the value c plus 2. Here there is no x, therefore the value remains same, c plus 2. For f of c, we have equal function is x plus 2, so it gives 1. Now in this question given the function is continuous, we put three values equal and then we find the value of c. Now in this function we have also three values, mx for x less than 3, n for x is equal to 3, and -2x plus 9 for x greater than 3. For left hand limit, we put in first function it is 3m. For right hand limit, we put in the last function, it gives 3. For f of c, f of 3, it gives n. At the end we put these values equal and it gives m is equal to 1 and n is equal to 3. Now in second part we have mx and x square. For left hand we put in mx, it gives 3m. For right hand we put in x square, it gives 9. For f of c and f of 3, it gives also 9. At the end we put these values equal and find the value of m. Do itself. Now here we have a function in two forms. One is for not equal. Not equal shows means left hand, and for right hand we apply the same function, and x equal to f of c, it gives value is equal to k. Now find the value of k so that f is continuous at x equal to 2. F of x is continuous is given. Continuous means f of 2 is equal to the left hand and right hand. Because there we have a not equal function, it means for left hand and right hand we only solve once. F of 2 gives the value k. In question we have at x equal to 2, it is equal to k. Now here we have f of x, we rationalize this value a square minus b square. Simplify the value, and numerator and denominator got each other, and then value, we put the value. So the answer of k is equal to 1/6. Okay students, try to solve all these questions. If you have any problem, then send it to me. Jazakallah.